Okay, in section 10.6, I want you to be able to identify conic sections and use completing the square to identify and graph conic sections. So completing the square is something that we did earlier in the year, and now you're actually going to use it to put conic sections in standard form. So just a reminder of what your conic sections look like in standard form. You have the circle, the ellipse, the hyperbola, and the parabola. Now when they're in standard form, if you don't have these identifications here, you can, if there's only one squared term, the conic section is going to be a parabola, because both all the circle, the ellipse, and the hyperbola all have two squared terms. If there's a squared term minus a squared term, the conic section is a hyperbola. That's the only one that has a subtraction in between the squared terms. But if there's a squared term and plus a squared term, then you're either going to have an ellipse or a circle. Okay, so this is standard form. Now, we're going to look at conic sections that can be written in general form, and you're going to have to be able to identify what the conic section is. So, the conic section represented by a general equation form can be determined by the coefficients of A, B, C. So, this right here only applies to standard form. Now we're talking about general form, and general form looks like this. This is the general form for conic sections. So remember, like lines, you have slope-intercept form, and then you have standard form, you have point-slope form. So this is just the general form for conic sections. Now, A, B, and C, all three of those cannot be zero. If that's the case, then this is going to turn into more, it's not going to be a conic section. There won't be any squared terms. Okay, so in order to determine what conic section you have, when it's in general form, you can't use these rules up here. What you do is you use the discriminant. And you've seen this before, b squared minus 4ac. And we're going to start out with the first equation and make sure that you are correctly identifying A, B, and C. A is in front of the x squared term, B is in front of the xy term, and C is in front of the y squared term. So for this particular question, A is 4, B is negative 10, and C is 5. So all we need to do is substitute those values into this and see what our value is. If it's less than 0, if it's greater than 0, if it's equal to 0. And because the circle and the ellipse both have two squared terms in addition, you have to, they're going to be less than 0, and then you have to look at an additional thing. So we're going to put those into, this is going to be your b squared minus 4 times a times c. That's going to be 100 minus 80. And that gives you 20, which is greater than 0. So if we go back up to the table here and we look when b squared minus 4ac is greater than 0, that's going to be a hyperbola. All right, now let's do another one here. We have to identify a, b, and c. Now sometimes you won't always have an xy term. So here you do have an xy term, and the xy term is going to be the b. So if this is gone, then b is going to equal 0. So just be real careful. Don't just think the first three are a, b, c automatically. All right, so a is going to be 9, b is negative 12, and c is 4. We substitute those into the b squared minus 4ac, and that's going to give us negative 12 squared minus 4 times 9 times 4. And simplified, that's going to give you 144 minus 144. Now that equals 0. So if we go back up to the table, we can see when it equals 0, it's going to be a parabola. All right, last one. Again, identifying a, b, and c. A is in front of the x squared, b is in front of the xy, and c is in front of the y squared. So we have 8, negative 15, and 6 for our a, b, and c. And substituting those into b squared minus 4ac, we have negative 15 squared minus 4 times 8 times 6, which simplifies to 25 minus 192, or 33, which is greater than 0. So the only one that we have to worry about when it's greater than 0 is the hyperbola. So we have hyperbola because it's greater than 0, a parabola because it's equal to 0, and a hyperbola because it's greater than 0. Okay, now we are going to take conic sections in general form, and we're going to change them to standard form. So just like you have changed point slope into slope intercept form, we can change from the general form of a conic section to the standard form, which is much easier to graph. Now, you can only do that if there is no xy term. If there's an xy term, then you can't do that. So the ones that we're looking at are not going to have an xy term. Okay, if there's one squared term, the conic section must be a parabola. So you want to look at that first, and that's going to tell you how to proceed with the problem. So if there's just one squared term, now this doesn't work if there's two squared term, there's a separate set of directions for that. So if there's one squared term, put the squared term and the corresponding linear term on the same side. Okay, so this is what we're starting out with. So this would be your squared term, this is your linear term. So we're going to put these two on the same side, we're going to move this over to the other side and this over to the other side. Okay, as you do that, we need to complete the square. And that goes back to earlier in the year. So if you need a review on completing the square, that's in section 5.4. Let's see, it's page 343. All right, so what we're going to do is we're going to do x squared minus 12x, and then we're going to add something, and that's going to complete the square. And then we're going to set that, we've moved the, we need to move that 36 over. Well, here, let me show you what I have here. We moved the 16y over to the other side. We moved the 36 over to the other side. Now we're completing the square with this. So x squared minus 12x. We need to divide the 12 by 2 and then square it. So that's what completes your square. So negative 12 divided by 2 is negative 6. We square it to get 36. Now, you need to make sure that you add that to the other side. Otherwise, we don't have an equation anymore. So we'll add when we added 36 here, we have to add 36 here. All right, now the reason why we did that is this is called a perfect square trinomial. We can factor this easily. And the rule to factor this is you take the square root of the first term, the square root of the last term, and this sign. So this is going to factor as x minus 6, because the square root of 36 is just 6, and then we square it. So all we did was rewrite this to make it look like this. Now, let me just show you. X minus 6 times x minus 6 is x squared minus 6x minus 6x plus 36. So it looks like the 12x goes away. It doesn't. It's right here. We just rewrote it, and I've been telling you all along, math is a lot about rewriting things. All right, now the negative 36, or the minus 36 and the plus 36 are just going to turn to 0, so now we have 16y. Okay, we know it's a parabola, so let's look and see what a parabola should look like. A parabola should look like 1 over 4p y minus k squared if it's horizontal, and it should look like this if it's vertical. Well, since our x squared, x term is squared, we need to have the y by itself, which means it needs to have a coefficient of 1. So all I'm going to do is divide this by 16. And now, instead of saying x minus 6 divided by 16 squared, this is like having 1 over 16. So I'm going to put that 1 over 16 out in front. Then I have the x minus 6 squared equals y. And there's my parabola. So it's y equals 1 over 16, x minus 6 squared. So this is the 1 over the 4p. Okay, so that's for a parabola when you only have one squared term. When you have two squared terms, you could have a circle, an ellipse, or a hyperbola. Okay, so when you complete the square, remember you need to factor out the leading coefficient of x squared and y squared before completing the square. Okay, so the first thing that we're going to do is rearrange all of the variables. So that all the variables are on one side and the constant is on the other. So that's what I did right here. I moved the 15 over to the other side. Okay, and I also put the x by the x squared, the y by the y squared. All right, next thing I need to do is I need to, and I think I'm just going to rewrite this out here, factor out the lead coefficient if needed. Well, this is not 1, so I have to factor out a lead coefficient. So that we're going to pull out a 5, and then we're left with x squared plus 6x plus, I'm going to complete the square here, so I'm putting a blank here. And then I have to factor out a 20 here, so plus 20. And then we have inside the parentheses y squared plus 2. I'm going to complete the square, so I'm going to put a plus 1 there. Or let me just put a blank there first, and then we'll go back and fill it in. Okay, and that's going to equal 15. All right, completing the square. I have 2 blanks on this side, so because it's an equation, let me slide this over here. I need to have 2 blanks on this side. Okay, so going back to this, I take the 6, divide it by 2, and square it. That's going to give me 3 squared, which is 9. Okay, now, a lot of times people just add 9 to the other side. You have to be careful. You have a 5 outside this parentheses, so you're really not adding 9, you're adding 5 times 9. So we're going to add 45 to this side. And then I have to complete the square here. The reason why we need to complete the square is we need our conic sections to look like this. X minus something or y minus something squared. And by completing the square, we can do that. So we're going to take the 2, divide it by 2, and square it, which is going to give us 1 squared or 1. Now, same thing here. I'm really not adding 1 because I'm multiplying the 1 by 20. So we're actually going to add a 20 to this side. Okay, so I'm just going to pick up over here now. We've added 15, 45, and 20. Okay, so basically what we have, I'm going to now factor this. So taking the square root of this, and the square root of this. We still have that 5 outside there, so it's 5. X, take the sign of this, so plus 3 squared. And then we have the 20 here. We're going to take the square root of y squared, the square root of 1. So it's going to be y plus 1 squared equals, and if we add those together, we're going to get 80. And then let's just ignore this right here. Okay, so basically what we have is this. Okay, now, this is addition, and there are 2 squareds. So we know it's going to be a circle or an ellipse. Now, an ellipse has to be set equal to 1. So this is what your ellipse looks like. So all we're going to do is we're going to divide by 80 to make that a 1. So when we divide everything by 80, we can reduce here. So what we're going to do is divide the numerator and denominator by 5. We're going to divide, just like reducing a fraction here. And when that happens here, we're going to get 16. So dividing this by 5, that goes away. It turns into a 1. Divide that by 5, you get 16. Divide this by 20. So you're not dividing by the denominator, you're dividing by the numerator. So dividing by 20, you get 1. Dividing by 20, you get 4. Now it looks like what you can use to graph an ellipse. Okay, you have a question to try underneath there.